Hello everybody. Let us continue onwards. In the last class I discussed about the charge, its characteristics, and also one important law used in analysis of the charge, that is Coulomb's law. And on the basis of Coulomb's law, it was also discussed the quantitative aspect of the charge, and it was finally concluded that what amount of charge and in what way this is declared and assumed and standardized as the unit of charge, and that is a coulomb. And it was finally declared, it was finally extracted that when certain amount of charge is placed 1 meter apart and a force of 10 to the power 9 Newton is experienced between them, then the value of charge, the amount of charge given on the bodies are called as 1 coulomb on each. The bodies should have or must have the equal values of charges in them. So whatever the equal value of charges are given on the bodies, then that value particularly is called 1 coulomb of charge. That was the thing last day I discussed. Also, the things to remember, I discussed about the unit of epsilon 0. In fact, about the epsilon, I discussed that this is the allowance or permission of the medium, extent of permission, extent of allowance of the medium for passing, for passing the influence of charge through them, and this is called permittivity. I told last day that for vacuum, this permittivity epsilon 0 is 8.854 into 10 to the power minus 12 coulomb square per meter square per Newton square, per Newton, sorry. Now, before I discuss onwards today about the concept, the meaning, and in fact the need of electric field, let us discuss about some of the problems, some of the numerical problems given in the book. You know, one problem is given in the book as example 1.5. A charged metallic sphere A is suspended by nylon thread. Let me show the figure also. Nylon, or another charged metallic sphere B held by an insulating held close to a kept at a distance between them is 10 centimeter. The resultant of repulsion A is noted, of course. Then the sphere A and B are touched by uncharged sphere C and D, shown in the second figure, and then C and D are removed and B is brought closer to 5 centimeter between them. B is brought closer to A. Now in that situation, what is the change in the force being applied in them? Spheres A and C and B and D are having identical sizes. See, when this A and B are charged, See, this is the whole figure. First of all, the two balls are kept 10 centimeters apart, and then C and D are separated, and then after separating, B is brought at the distance half of the previous distance. So you have to calculate in this situation the change in force. So let us assume charges on the spheres A and B are Q and Q dash. The force existing between them is F equal to 1 upon 4 pi epsilon 0 into Q dash upon 10 square as separation between A and B is 10 centimeter. A point, this you keep. When identical spheres are placed in contact and separated, equal distribution of charges take place. So on a sphere A, Q upon 2 charge remains, and on B, Q dash upon 2 charge remains. So F dash equal to 1 upon 4 pi epsilon 0 into Q upon 2 into Q dash upon 2 upon 0.05 square. So keep it as Q dash upon 4 . QQ dash upon 4 into point 1, yeah, keep it like this, 0.05 into 2 upon 2 square. Just for the sake of your understanding I am giving this, that is QQ dash upon 4, 1 upon 4 pi epsilon 0 into 0.1 square upon 4. So this 4 is cancelled, and you have 1 upon 4 pi epsilon 0 into QQ dash upon 0.1 square, and that is equal to F. So this shows that there is no change in force when this is done. Now there is one more thing. Now before I discuss about one more problem, or let us consider one more problem. It is given here that consider the three charges Q1, Q2 and Q3, each equal to Q, at vertices of an equilateral triangle of side L. What is the force on charge Q? Placed at the centroid of the triangle as shown in the figure. Here on these three, the charges are kept, Q1, Q2 and Q3, they all are equal, and here when a charge capital Q is kept on the centroid, it is telling about the resultant force acting on it. Now before I discuss this problem, let me tell you one thing, that as Coulomb's force is a force, of course it is a force, and it is a vector quantity. So when a charge is kept under the influence of more than one charged body, then on a particular charge, each and every charge will apply its influence. So let us say that so many charges Q1, Q2, Q3, Q4, Q5, so many charges are kept in the environment, and one is testing the resulting force by the influence of all the charges kept around. Then this is a common phenomenon in mechanics also. We people have studied that when more than one forces are being applied on a body, then the body experiences the resultant of all the vector sum of all the forces is the resultant, is the final result being experienced by the body. So the same, since Coulomb's law is visible, is experienced as a mechanical force, so more than one charges are there in the environment, each and every one will put its influence on a particular charge. And here also the final is considered as the vector sum of individual forces being applied by that particular test charge, and this force is evaluated on the basis of Coulomb's law. This is a simple process. So we have the equilateral triangle. Let us say the vertices are A, B and C. Either you tell perpendicular or median or whatever you will tell, they all are meeting at one point. Let us say this is point O and charge Q is there on this, whereas on these vertices equal charges are there. This is example 1.5. You know, equal charges are kept at all the vertices of the triangle of equilateral triangle, and say Q and a charge capital Q is kept at the centroid. You know, it is to recall some of the concept of solid geometry, that the perpendicular from the opposite side of a triangle, the perpendicular on any side from the opposite vertex of a triangle passes through the centroid. That means the perpendicular is also the median. So, and in equilateral triangle, the angles, all angles and all sides are equal, since sides are, since having, write like this, having the side L perpendicular AD passing through the centroid O will be L sine 60 degree, that is root 3 L upon 2. One more concept of solid geometry is applicable here. This tells that the centroid divides the median of a triangle is to 1 ratio. So AO in the triangle will be root 3L upon 2 divided by 3 into 2. That means this will be the 1/3 part and twice of this, and that is L upon root 3. Centroid being in equilateral triangle, all the vertices are equidistant from the centroid and that value here is L upon root 3. So all the three forces acting on the centroid are of value 1 upon 4 pi epsilon 0 into q square upon L upon root 3 whole square. That is 1 upon 4 pi epsilon 0 into 3q square upon L square. Now let us consider direction. In this figure, suppose the forces are F1 at B at A, F2 at B and F3 at C. Then F1 will be in this direction, F2 will be in this direction and F3 will be in this direction if the value of charge is same taken. So here this is the direction of F1, this is the direction of F2 and this is the direction of F3. Now the resultant of F2 and F3 will be in this direction, that is F2 plus F3, they are the vectors. Now as the angle between these two, and since F2 and F3 and F1 all are same, only the directions are different. So F2 plus F3 equal to, its modulus is, you know that you can write like F square plus F square plus 2F into F into cos 120 degree का square root, and that is equal to f. Because you see cos 120 degree is minus half, so by minus half this 2 will be removed and this will remain f square here. So by 1 f square is cancelled and f squares under root is f. So this f is in this direction. It is found by the diagram that the resultant of f1 and f2 and f3 is in the direction opposite to f1. Thus, net force on the charge q at centroid is 0. This implies that f1 plus f2 plus f3 equal to 0. So this is specific problem. There is one more. See the book. Consider the charges q, q and minus q placed at vertices of equilateral triangle as shown in the figure. See, consider the charges q, q and minus q placed at the vertices of an equilateral triangle shown in this figure. What is the force on each charge? Now it is asking. So this is example. (1.7). You have this equilateral triangle. Let us say the vertices are A, B and C. Let us say here it is plus Q, here it is plus Q, here it is minus Q. Let us say its length is L. Now it is to find the resultant of force on each of the vertices. First of all, let us consider the vertex A first. At A, the forces at A, force due to B is one upon 4 pi epsilon 0 into Q square upon L square along AB. Being opposite charges. You can clearly observe in the figure that Q and minus Q plus Q and minus Q are there. So the force of attraction will take place and A will tend to move towards B. So along AB I have mentioned. Force due to C is again one upon 4 pi epsilon 0 dot Q square upon L square along AC. You have same situation. So it is AB, another force AC, the angle between them is 60 degree, resultant will be in this direction. Resultant will be along AD having magnitude equal to F square plus F square into plus 2F into F into cos 60, let us say 1 upon 2. So 3F square square root, and that is root 3F. Now let us think on B. B, the forces on B, the forces are due to A and C. So forces at B are due to A and C. Due to A, the force is, see the direction, the force is towards A, that is BA, and due to C, the force is opposite to BC. So one force is along BA, another force is opposite to C is this side, so it is repulsive opposite to BC. This angle is 120 degree. So the resultant is in this direction at an angle of 60 degree from AB, or at an angle of 60 degree from BC outside. So this resultant is F square plus F square plus 2 into F into cos 120 is minus half, that is F square plus F square minus F square, so that is under root is also there, that is F at an angle of 60 degree outwards from side AB. And similarly, forces at C due to A and B are due to A force is along CA and due to B force is opposite to BC. Forces along BC yes. So this is the resultant is in this way. The situation is same as it was at B. So the force at B is force at C is F at an angle of 60 degree from side AC. That's it.